to our first afternoon session. I am very pleased to have the acceptance of four esteemed speakers who have kindly agreed to join me here on this in this role, where I play the moderator, but actually I'm surrounded by four subject matter experts who will be instrumental and crucial for having this discussion together with you. It's a topic that is highly relevant, we find. It may sound a little bit technical at a first glance when you look at the title of our topic. Use of ADSL instead of ADSB over SRD 860 frequency band. We will discuss what that means. And mobile networks to support low-level airspace traffic integration. So a very technical entry. We'll put some practical meat to that during our discussion with your help. It's a topic that concerns general aviation enthusiasts and airspace users and remote pilots likewise. So this is where we bring the two worlds together, and we bring a third world together, and that is something that EASA typically is not an expert in, and that's mobile network operations, mobile telephony. I'm very pleased, and I'm to introduce to you, and I start here in the sequence as you can see it, so we don't mix things up. I'm happy to welcome Andrea Annesini, who is the president of Europe Airsports, which is a strong voice of sports and recreational aviation in Europe. And Andrea is a lawyer. He has a strong managerial background in the financial and automotive industries. He's also holder of a private pilot license and several other microlight licenses, so an aviation enthusiast, by the way, like myself. Welcome on this panel, Andrea. I'm also joined by a very good colleague of mine, Vlado. We know each other for quite some time, but Vlado, you have a very distinct area of specialization in EASA. Vlado works in the general aviation and vertical takeoff and landing, so VTOL department of EASA as a project certification manager. Our acronym is a PCM, for those who are familiar with it. He's also an ATM expert. And by the way, Vlado is also a glider pilot and a very active one, no? Yeah. During your spare time. Yes. So, Vlado is the agency's focal point for airborne collision risk, something that we also call I-conspicuity, so electronic conspicuity, as well as a passionate aviator, as I have mentioned. He is very passionate also in this particular subject matter. And Vlado is of the opinion that pilots are now ready to embrace new affordable technologies if they come with improving safety. That's one of the core themes of our discussion. To my left, Thomas Neubauer. Thank you very much, Thomas, for joining us. Thomas is Vice President of Innovations at Theoco and co-founder of Demetor. And Thomas is passionate about an airspace connectivity analytics platform that is called Airborne RF. You will explain us a little bit what that means. He serves at the board of directors of GUTMA, the Global UTM Association. And Thomas also leads the work for global data interface standardization between telco, networks, and aviation system. So we're bringing here together the two worlds that I have mentioned previously. And finally, Toby, also thank you for being with us. Toby Potter. He's the head of business development for Europe at OneSky, the leading, I shouldn't say that, I should say a UTM, solution provider for BVLOS and advanced air mobility. Thomas sees the use of cellular as a key enabler in enhancing airspace safety at low level, creating the environment for more commercially viable uncrewed operations in the future. With this intro round, I hope EASA has succeeded to bring together a relevant mixture of stakeholders to this discussion. We would like to engage with you as audience, both here in the room, but also where connected and joining us remotely. We have, and most of you will be already familiar, where is my push button thingy here, by the way? There it is. We have this slide here. So please connect with us using this Slido tool. This will be the tool that we use in order for questions from here in the room and outside of the room to reach us, and we will, time permitting, obviously be very happy to address those questions. You can actually even, you don't need to necessarily ask new questions after all, but you can see what the other colleagues have already put into questions, and you can upvote questions that you like, for example, by means of I like, and then it climbs in the sequence of priority. So, I would like to head off with inviting every one of you, gentlemen, to make your entry statement using a short pitch. Something that is close to your heart, why you're here, the key points that you'd like to bring across, that will also serve us for our discussion later on, okay? And in our given sequence, we start with Andrea. Please, the floor is yours.
Thank you, Sasha. Thank you to EASA, because it is a very important opportunity for us to speak to a large audience like you are and to clarify, starting from complexity. I'm sorry, but I have to start from complexity, because as you can read on the first slide, Europersport is the association, the non-profit association that represents 700,000 airspace users in Europe, starting from the lowest segment, more than 200,000 model aircraft users, the old brother of drones, perhaps in some way we can say, until the very high and low percentage of lucky pilots owning an IFR, general aviation aircraft. In the middle, there are something around 80,000 gliders, and I will refer to them about FLARM, and 150,000 paragliders, which are composing the youngest and the most proactive segment of our constituency, and these are probably the target for the mobile phone-based technology to serve them with. I try to explain to you why we support new technologies and new regulations. Thank you, sorry. Speaking about money, because this is the crucial point for us. If we assume that a general aviation two-seat certified light aircraft, like a Piper PA-28, like a Cessna 172, costs something around 250,000 euros, the installation of a certified ADS-B device, including installation, average price, percentage, incidence of the cost, is 2.8%. The cost of 250 euros is probably lower than the effective one. In the world of micro and general aviation, in that segment, unfortunately, is decreasing the number of pilots and decreasing the number of flying aircrafts. The microlight market and the microlight activity is relatively in good health, but the average price of a microlight aircraft is about 110,000 euros. The installation of a non-certified ADS-L device, I'm referring to the FLARM price, but we can think that in the future the price of an ADS-L solution would be the same, is about, I calculated about 3,000 euros. The percentage incidence of the cost is about 2.7%, so only a little bit lower than the solution, the certified solution for general aviation. But paraglider, which is a community that we want to defend, is a totally different story. Because paragliders are young, brave, and in a given sense, poor, because they are students, they are very young people, they are generally, they love very much mountain because they have to climb up, sometimes with a car, but sometimes by themselves. And the cost, the entry level average price for a paraglider wing is 1,500 euros. So if we think about what we hear about what I call the matchbox, the very light to be seen device offered by some institution, even someone that has a stand here, is about 400 euros. That means that the percentage incidence of the cost should be 27.7%. It means to kill the sport. It means to kill the activity. It means to, at the European level, to decide that the European community, in a very large sense, is not interested in protecting this kind of sport that could be, pay attention, a very important factor in order to refill year by year the other communities of pilots, the other communities of sky lovers that we need to continue to support in our continent. The last slide tries to sum up our point of view in terms of what we need, that the solutions regarding the EU space administration should be safe, according to the principle of the basic regulation, that an high and uniform level of civil aviation safety should be ensured at all times, not only for general aviation, but for every kind of flying object in Europe. And I'm very happy to say that finally EASA understood perfectly the problem, which is a safety problem, not a political problem. Free for our airspace users, because the only beneficiary of the provided services will be drones. Simple, by ensuring that the administrative and operational requirements for access do not add a layer of complexity to planning and conducting a flight. Technologically feasible, considering the very limited resources of light aircraft, in particular non-motorized ones, such as gliders and gliders and paragliders of even. This is our philosophy. We communicated publicly our point of view 3 years ago, 4 years ago. We found, I have to admit, no, I'm happy to admit, that we found a great attention in EASA, even if a great portion of the constituency I was referring to, 150,000 paragliders, more than 100,000 microlight pilots, they are out of the scope, of the formal scope from a juridical point of view of EASA, but not the problem of granting safety on the European skies. And we are very happy to be here and declaring that EASA did a very important job to help us to understand, even if we know that solutions are still to be discussed and fine-tuned. This is our point of view.
Thank you, Andrea. This is a very clear statement from a very important community that has to be heard, obviously, when it comes to U-Space implementation, or generally speaking, the use of very low-level airspace in particular. that is well heard, and I'm very happy also for your concluding remarks in the sense that you felt to have been heard in that process, which, by the way, hasn't been an easy one. And that is a nice transition, actually, to Vlado, because Vlado knows about the complexity at stake here. One may think, what's the issue? Something that flies can be made electronically visible to very easily, right? Theoretically, yes. In practice, unfortunately, not always that easy. Vlado, can you maybe build on this with a story that, apart from you being also part of Andrea's community, by the way, at least in your leisure time, but in your professional capacity at EASA, you had to also consider the other complexity layers, if I may say, in that game. Vlado, can you share a bit, shed a bit of light on that, please?
Thank you very much, Sasha. Good afternoon, everyone here. Really pleased to be here in this interesting panel, and indeed the challenge was high. And I will take the perspective of the regulator. Of course, I felt the pain as a pilot. So I fly sailplanes, I fly powered planes, and I have my gadgets in both planes. But I felt the pain, and I feel it. What does it mean to operate these planes and to invest into additional equipment? But in EASA, we were facing the challenge of U-Space coming, but we were facing also another challenge here. And our challenge was when the drones started to reserve their airspace, we have realized also that we have a growing number of fatalities in airborne collisions in Europe. And that was our primary concern where we started. So we had to look at it at that time, back in 2018. And we realized that there are major flaws in how we are flying in the air and how pilots are capable of utilizing or relying on see and avoid principles. So there are major flaws in see and avoid in a very dense environments where pilots are simply hitting each other, not seeing each other. And we have now a growing number of fatalities in Europe. So that was our challenge there. And then we were having this certified world of EASA. Then we were having the non-certified world of aviation community developing their own solutions to protect themselves, to protect the participants. So one well-known example is FLAM. Company started like 15 years ago, introduced the collision awareness device for gliding community that instantly got adopted voluntarily by pilots. So that was at the time, I mean, we could have like something like 50,000 of these devices in Europe over 15 years. So that was the adoption rate. So not bad, really, helping a lot. And we were having a challenge of making people visible in the sky. So what we have taken, we need to develop, we understood that we need to develop something new, because when looking at the certified technology, we have realized that technology is not suitable for certain airspace users. And building on the presentation from Andrea, certain technologies are not affordable. And here, please understand affordability from the perspective of the user, not from the perspective of a regulator. What we think is affordable to you. No, pilots decide what is affordable to them and what is not. And they value the benefits. They are used to do so in many other instances, why they couldn't be capable of doing the same when analyzing this. So we came up, we were actually forced to come up with something new. And you know, as a regulator, we often rely on standards and specifications. And we understood that there is no aviation standard specification out there. There was nothing else available. But there was some good work paved by these communities developing their own solutions. We have quickly understood that we need to put them on the same grounds quickly, so we engaged them very closely, and we were working with them, and we came up together with the ADSL. So ADSL stands for Automated Dependent Surveillance, but L, this little difference compared to ADS-B, stands for light. And in translation, it means that we have been trying to create a language, transmission language, to be seen in the air electronically for the lightest denominator. So to set the foundation, what is absolutely necessary for the function of being conspicuous in the air. What we have done, we have taken ADS-B out, very well-known, respected international standard, and we have started to strike out any unnecessary parameter. And one of them, as you can imagine, was pressure altitude, because we have realized for this functionality to separate from drones, we do not need a pressure altitude, but we need the GNSS altitude there. And for simplicity and affordability of the final solution, we need to rely on only one source. So we came up with the ADS Lite proposal, but that's not only for making planes visible. It's designed in a way, the language, the protocol is designed in a way to allow for uplink of the traffic information to help us to solve the problem of collision among manned aviators. So we were having a poly problem, sort of. We were having a number of problems we have to solve at the same time, not necessarily by a unique solution, but various solutions. Moving forward, we've had the language, but we have to decide on how to transmit this information. And of course, people may say, okay, let's go for 1090. That's out there. Okay, we have a lot of concerns in 1090. We said, okay, if you are certified technology, ADS-B out, there is no concern, that's all good. But can we move all this community, 700,000 or let's say 500,000 people into 1090 channel? And we quickly realized that's not an option for us. So we understood that we will need to probably rely on additional channels, and we understood that these channels will not be necessarily aviation certified, because there are other options there. So we came up with a proposal to transmit ADS Lite over SRD 860, which stands for Short Range Devices 860. It's a range of numerous frequencies, like for this one, or your garage doors opener, but there are three distinct frequencies which are suitable and used by traffic collision avoidance devices today. So we have defined those frequencies, defined the way to transmit the information in a specification called ADS-B for SRD 860. But we didn't stop there. That's the devices which are already out there, so we are harvesting on previous investments of the pilot. But there are also newcomers like paragliders growing, the only growing market in light-end aviation. So we said, okay, can we use ADSL for mobile telephony? And the answer, we didn't know when we started, but we asked for the study, and the study answered, yes, this is feasible under the certain conditions. We have to develop the standard specification, make it legal, make it possible in Europe, and on top of that, we still need to develop the ADSL for mobile specification to make it happen. So what's new in all of this as a regulator, and this is what I would like to conclude with this, we have stepped outside of certified aviation, we have stepped outside of certified spectrum for aviation, and we have introduced safety-related, not safety-critical, but safety-related function based on non-aviation spectrums and non-aviation technology, but based on standards and available across Europe everywhere. Thank you.
Cool, thanks Vlado. Now this is a good real-life example of, if I may say, without or with a bit of pride for our own organization's creativity and thinking, even as a regulator, a bit outside of the box. It reminds me very much of a previous initiative in which I was involved, which was called the Net Safety Benefit as part of the GA roadmap, which followed a very similar approach. So what is the net safety benefit if we left everything aside in terms of constraints that remains? Is it a plus? Do we have a plus for the benefit of safety as compared to when considering the residual risks, or is the balance negative? And this is, I think, yet another good example where the common denominators have been identified in a very pragmatic way, and I hope that now with this we can make the bridge to the telco world. To my colleagues here, to my left, we have previously heard, Thomas, that You're busy, well, three names. I need to read it again. Teoco, Dimitor, Airborne RF.
Right.
Can you let us know what is behind those?
Sure.
Here is your push button, please.
Yes. So it all starts with that picture, which actually shows a segregated industry, which is, on one hand, you have aviation, which has nothing to do with telecom, mobile phone networks at all so far. It's switch off your mobile when you're on a plane. So it's a negative impression that you have. It's something bad that you have with currently with aviation and telecom. But and the reason for that is very simple, that in general aviation you have everything that is, from a legal perspective, essentially on the plane. Most importantly, you have a pilot in command that sits on the aircraft. That very same rule with having a pilot in command is true for a drone that will fly beyond visual line of sight. So the question is how to control a drone flying beyond visual line of sight to satisfy the pilot in command requirement. You need to have a reliable digital communication. And that is happening with cellular. Because when we're looking into the lower airspace, what is really important with cellular is it is there. It actually serves very well the lower airspace, not everywhere, but where it is. And it contains actually a lot more additional information that might be very interesting for aviation safety. So number one, in order to get a flight approval, you want to know where you have connectivity, because if you're flying beyond visual line of sight somewhere where you know that you're not having connectivity, it's a safety concern that is not necessary. The second one is telecom networks have excellent information about dynamic information on ground risk rather than census data, which tells you where people are. I'm not sure how many people here in the room are registered in Amsterdam and show up in the census data. You certainly show up in the mobile network data. So just to give you an idea on ground risk applicability. And of course, cellular networks can give you a very good understanding of GPS or GNSS independent information about positioning. So a lot of redundant information that can be provided from the cellular industry into the aviation industry. But going these 2 steps back, historically, there was no interface. The data wasn't needed, so there was no data exchange feasible. And in one of these roles that I'm actually taking care of, we have, as an industry, set up interfaces between the telecom industry and the aviation industry. Something that is called, another acronym, ACJA, Aerial Connectivity Joint Activity, which is set up by the industry consortiums of the telecom operators and GUTMA, the Global UTM Association. And the key purpose is to find a standardized way of exchanging data so that the aviation industry can benefit from the information that is available at the telecom networks. That information at the telecom networks is usually highly classified. In some places, in some countries where you may be at home, it's a matter of national security not to share telecom network information. So we found a way with our solution and some standards that we developed called Airborne RF to exchange the data, the necessary information in a safe, secure, reliable manner, handling GDPRs and so on, and to directly interface that data into the management platforms, the UTMs, the aviation control systems, FIMS, ASIS, you name it, on the aviation side, to get visibility on what happens in this digital airspace. That is sort of what it comes together, and I'm representing a couple of companies, primarily on the telecom side. Airborne RF is just the product and the solution that we have deployed. But the important point and the key statement I would like to make for this panel discussion is there is technology out there that gives you, like in this picture, a holistic understanding of any airspace if you have sufficient connectivity in the airspace to handle C2 connectivity for a BVLOS flight, payload connectivity, for example, any first responders. We have, for example, first responder services in parts of the world where it's necessary to bring back a video signal, otherwise it doesn't make sense that mission control has some sensor out there but no visibility at mission control. And thirdly, for visibility aspects, I mentioned here network remote ID is just yet another visibility aspect, information that can be provided through networks. That's what the statement is that I would like to add. Technology is there. Cellular networks are very well suited for the lower airspace. That's my statement.
Danke, Thomas. Thank you. So, technology is there, a key statement we take from your opening pitch, and I'm sure that Toby will in a short while add on this. I must say I liked very much this picture that you painted about this negative connotation that everyone has in mind when entering a commercial airplane. This is forbidden. Don't use this. It's bad, actually. Yeah. So what we try to reverse this now into something good. Correct. And beneficial for safety. Not only beneficial for safety for this as well. Yes. Not only beneficial for safety for the conventional airspace users with the pilots on board, but also for the remote pilots in the future. So jointly, and maybe that makes a good transition, Toby, to you. How can we bring those two worlds now together, and what is the added value of OneSky to that? And where is the push button? You already have
it. Okay, we have that. But thank you, Sasha. And I guess where we fit in this is we've heard about some standards and some potential end users and the importance and the type of data and information that's available out there. Our job as a UTM is, first of all, to make sure everybody's operating in a safe manner, but it's really to utilize the data that is available out there to assist in increasing that safety whilst enabling operators, those people that want to use the airspace, to both operate efficiently in a commercially viable way, and but also as part of their planning process to utilize that information to say, if this is the mission I want to achieve, this is the flight I want to achieve, what is the best and most efficient way that I can do that in a guaranteed way? So if I'm using a drone to simply survey a building, but I want to stream that back to a central source, then I know I need a high level of, maybe it's 5G connectivity. How do I understand where that is? And how do I understand how I achieve that without access to that data and that information in the correct manner, protecting privacy and so on? And that's really where OneSky sits. One more. We provide that UTM capability. So we serve really three constituents. There's the airspace regulators and the ANSPs, those people that manage the airspace out there today, and who will probably end up deploying a SIS or that kind of environment that provides data and information out to the operators. We work with those operators as well out there, but we also provide an operational modeling and simulation capability that comes from our heritage of simulation in the world of aviation. And the point of describing that is all three of these different environments require not just data, but data in a reliable, usable manner that we can utilize to provide and to analyze and provide information to our end customers and users so that they can take intelligent, safe decisions. Okay. Data can be interpreted in multiple different ways by each and every one of us. I'm sure we've got different ideas about how you would use that data. But in order to maintain a safe operation over a period of time in a consistent manner, and over time that ends up potentially being certified to a certain level of safety, that has to be consistent and pass certain tests along the way. So that reliability and analytical capability is fundamental in being able to do that. And just to bring that together, this is how we utilize data. This is just a visualization. We do all this internally in our system. This is the city of Singapore, overlaying different pieces of data and insight so that as you look at where you are operating, you can understand what are the safety implications of doing this? What is the risk, and how do I quantify and measure that risk of operating in that environment? And does that environment support my objective of the operation? If it is a long BVLOS flight, for example, I don't want to fly and then get to the other side and not be able to transmit the pictures back, right? I need to understand that environment that I'm operating in. And that's the fundamental piece from our side, is utilizing those standards, the data, the information, and providing insight to drive that safety, but also operational capability in the uncrewed market.
That's very impressive. Thank you, Toby. Let's open the floor now for our discussion. A quick time check. We have something like half an hour to go. We already have a few questions on Slido, so just a friendly reminder, please, if anything pops to your mind, chip it in the Slido, and we see that we can address most of your questions. All this only works, I think, when the telco providers, the telco operators collaborate with aviators. No? So I was wondering, what's the stance? And this is not their primary business. So a telco operator's business is if I may say, selling SIM cards by the hundred thousands, by the millions, not to a few paragliders. That's not really their core interest or their core market. So we need their buy-in, obviously, apart from the technological feasibility in terms of the terrestrial stations that they work out and provide the connectivity and coverage, but we also need the telcos to understand the needs of aviators and to accept their role and their share in this game when it comes to improving safety for aviation. Can you maybe share a little bit your experience? What is the this must have been something new to the telco operator world as well, no? When we approached them, we aviators.
So if I can directly add on that, because that's straight into where I actually work on the standardization, where we have about 60 telecoms around the world actually coming together to actually trying to engage in what I call a digital airspace, because for them it's not, they don't see it as aviation, because if you look at it from a slightly different angle, a drone is really just nothing else than a sensor or a IoT device, and the drone, the flying aviation part, is the taxi for having that IoT device moved around in space. Because if you look into some of the application cases like a power line inspection or a rail track inspection, some of these drones are generating something like 1 terabyte of data per hour. So you want to transmit that data, you want to store that data. A public safety aspect is you need to transmit the data to a mission control center. So it's a sensor transmitting information through cellular environment in a broadband manner in a lower airspace. So telcos actually see that more as a digital infrastructure for this lower airspace. And by doing that, obviously the entry ticket is to make sure that the safety concerns are actually addressed. So it is. It took a little bit of time, as you absolutely correctly said. The core business of many telcos still is to be, selling SIM cards. But an important aspect is the biggest fear that telcos have is ending up as a bit pipe. So they are trying to add value to adjacent industries, to IoT industries, to the digital airspace as such, aviation as such, public safety services that are delivered by drones, helicopters, and so on. It's a question of how to digitize the airspace. So far, the lower airspace is actually not really provided with any proper broadband connectivity. And that is, they consider that a growth area. And that's why they're engaging. And as I mentioned, we have some challenges when it comes to language. Telecom and aviation sometimes uses even the same words for something very different. So it's a learning process, but it's a learning process on both sides. And I'm leading one of these work groups that is having about 60 telecom operations from around the world, because they all face the same challenge. How can they engage? And what is appropriate, because not everything that is technically feasible is okay for and acceptable for aviation. That is new to telecom. That is new. If it works, is the telecom paradigm. But in aviation, that's not the point. It needs to be certified. So that's why we are actually in the process of getting data interfaces standardized of what we are doing right now. 3GPP release 19 will actually have those interfaces as part of the global telecom standards incorporated, because in some countries of the world, the UTM provider and the telecom provider will be the same entity. So that's why there is a vested interest to see how they can engage in this aerial IoT business. And for that, airspace digitization is a must-have, and that's why they are some getting it already. We're here in the Netherlands. KPN has announced that they have such capabilities operational today. So it's not 5 years in future. It's happening. That's the key point.
Aerial IoT. Okay, that's something new. I think we have to also embrace in our aviation dictionary in the times to come. But it makes total sense. So thank you for this. Equipage and voluntary uptake and reservations. Andrea, where do you see the greatest opportunities in the uptake of this, what we discuss here, in the community that you represent?
I need to share between different components of the community. I mean, and the very clear point that we have to keep in mind is that there is a component of the community that flies in a way that gives them the chance of receiving an order or an advice and perform a change of the route, an increase or a diminution of the flight level, etc. All the communities I was referring to, apart in a given sense for gliders, because gliders, they can diminish the flight level. They have some difficulties in turning right and turning left, but they cannot increase the flight level because of the or only in the case of thermal. But if you receive an order, increase 200 feet, and you do not have the meteorological condition to do it, you cannot perform. In the case of paragliders, they are totally unable to receive an order and to perform it. The distinction is necessary to understand why paragliders, they say, we can accept the idea of being conspicuous, but there are no reasons why we should be able to receive information because we cannot perform it. Think about the idea of flying with a microphone and something on your hands to look at what is going on and perceiving the presence of other flying objects, drones, for instance, on your route. It is not feasible. So there is a category that says we accept the idea of become conspicuous, But all the other categories, they could even accept the idea of understanding, receiving orders or receiving informations and perform according. I've seen, if I can answer to the first question.
Oh yes, this is a welcome opportunity. But thank you, Andrea. We see here our Slido screen, and in fact, thank you for those who have come forward already with questions. We will address them on the fly and not in segregated manner. Please, Andrea, I welcome this.
It is very close to what I said before. The Paraglider European Union believes that, according to their information, they have an important safety department studying and publishing every year information about the collisions or other the accidents, and the percentage of the accidents due to collision on air is very, very low. They are worried about what could happen to them when, in the case they fly in an area where drones could fly together with them. In that case, could become possible a collision. So they say, for the time being, we do not see any reason why we should pay for a service that we do not need is useful for us. Totally different story, the cost of an app. I mean, the cost of an app could be even discussed with them, but the cost of an app could be 10 euros per year, 5 euros per year, not 400 euros for an apparatus plus the cost per year to be served.
Okay. Because our audience will probably not see the questions that we see here on the screen, it makes sense to briefly repeat them before we address them, so that everyone is clear on what we are talking about. Okay, thank you very much from the back. So everyone can read what is the first. I suppose it was mostly the first question that you have addressed, but
yes.
in part, I think you also addressed the question of devices. So, do we need new devices necessarily? Do we need new hardware to plug in our anyway already dense cockpits? Do we need stuff that is be put on the drones, for example, in addition to what we have?
Can I answer with our experience? It's not my experience, it's Vlado's experience. I mean, we have something around 80,000 glider pilots in Europe and something around 10,000 aircrafts in Europe. We do not have very, very clear statistics, but reasonably, 50% of them are equipped with a FLARM apparatus, which is an ADS-L apparatus, I mean a non-certified apparatus. But pay attention, this is a solution that has been both by these glider pilots to be installed in these glider aircrafts, which are engaged in competitions. In a general sense, FLARMS is poorly used when pilots and aircrafts, they fly for leisure during the weekend. So the answer, according to our experience, the answer is yes, it is possible, something exists. We are conspicuous. A given portion of our constituency is not only conspicuous, but can receive orders, because with the FLARM on board, they can receive informations, which could be the cost of a device deployed in 100,000 pieces all around Europe. That's a question mark for us.
Okay. Thanks, Andrea. I would like to come back what Thomas had shown us in his opening pitch. And that is, I think, one thing is when we purely speak about conspicuity, in the sense, is a strange word. I had to get familiar with this. So conspicuity effectively means visibility. Here, electronic visibility, right? So to make yourself seen and be seen, or to see and be seen, I should better say. under proper native English supervision here. So that's one thing. That's the core. That's the safety essence of what we talk about. But then we have other aspects going beyond the pure essential safety notion. And that can be something that is more related in terms of information for the mission. Something that is, when I'm sitting in my little Mickey Mouse aeroplane and I don't want to hit a drone, so I would rather like to know where the drone is, and likewise the other opponent as well. Because it's me sitting there, I want to protect my bones, my life, okay? So I have a vested interest in knowing what's around me. So that's my essential safety interest. But apart from that, maybe I get a bit of an extra incentive to take a bit of money in my hands and to install something, be it an app or be it a hardware device at reasonable amount that is reasonable to me, to my personal perception, as you rightly said, when it comes with a little bit of an extra incentive, such as, I don't know, can I also have a data uplink and know where's the next cold front, weather front in front of me, in real time, for example? So can we incentivize that's my point effectively, can we potentially incentivize voluntary equipage by offering extra services that go beyond the pure safety notion?
Yeah, it's a really interesting area. And just for the previous question as well, as a UTM, we're interested in the data. Really, I don't care what device you have, but what I do care about is the quality of that data and the information coming from it and how reliable it is. And that, therefore, does impact on what device you're operating. So for us, I'm going to be very vague and say it has to be a cost-effective solution. That doesn't necessarily mean free, but equally, I understand the point at the end there. It doesn't need to be 500 euros, 1,000 euros to put this thing on my device, because that impacts my commercial ability to do my job. Utilizing that data, let me come back to the previous one. We have to remove the barriers to allow people operators to deploy these devices. So the cost-effective piece is the first one. The first thing you look at when I want to buy something, it's too expensive. That's your immediate reaction. So make it the right price for the capability that you need. Make it simple to use. Most drone operators are not general aviation pilots. They're not familiar necessarily with airspace as a pilot would be. And so making the device or the app as simple as possible encourages that uptake as well. It's really about removing those barriers to entry. And once you have that, the next stage is then, again, as an operator, I want to fly from A to B. I have these safety parameters in order to operate. Please give me the most effective route that maintains connectivity, provides me with the right level of bandwidth, for example, for my service, ensures the safe operation, so I'm not flying over large crowded areas, but allows me to deliver the work in an efficient manner. There is nothing more frustrating, whether you're an operator or just going to work and having to, I forgot my notepad and pen, I have to go back, right? I've just lost an hour because I had to take a taxi back to my hotel. There's nothing more frustrating than turning up somewhere to do your job and not being able to because the connectivity didn't allow me to do that. I couldn't operate safely. The weather was bad. All of these capabilities come together to enable this. But ultimately, it's about removing those barriers and making this easy for end users.
Yeah, I agree with that. Vlado, let's have a look at the screen here. And there's also, we're sticking to this device and price tag thing for just one more moment, but then I'd like to also touch upon another topic afterwards. Where is that question gone now? It was around there was one question which was about when can we actually expect the first such devices that to be available on the market?
Sasha, I think I'm proud to say that thanks to the uptake and willingness and cooperation of the industry of non-certified devices, they were basically helping us to develop the specification, which is out there for SRD 860. So you can find it on ADSL for SRD 860 on the EASA website. They helped us to develop this specification, and all of them, both paragliding, gliding, and others who are using that spectrum, committed to upgrade their devices, existing devices, with these specifications. There are several ways how to do it technically. It's up to them to sort it out, but there is a commitment. They have participated to this work to unlock the access to use space to their users, to their customers. So they were having a customer perspective. So this should hopefully be done by a software update of existing devices. And of course, we expect that all the new devices that will be coming up to the market will be respecting the specification that is agreed upon. The same will go for ADSL for mobile. We are still about to develop this year, and there is an even greater prospect for that because of it's a network connectivity. It goes both ways, and it may provide some very useful connectivity for GA in flight. We all of us who fly, we fly normally with mobile phones, not because of connectivity, but in case something happens, we want to have a mobile phone for our own security. So the device is typically on board. On board in terms of paraglider, it's in the pocket or backpack or somewhere there. So, and by the way, I can imagine paragliders, so if they are not flying long distances, they will use something like that. This has an electronic SIM card in there.
A wearable watch, yeah.
And so there is a great potential. We want weather into the cockpit. We want real-time airspace. We see a great potential in GA for dynamic airspace configurations the drone industry is bringing. So we stopped talking about GA, them, drone industry, them. We talk about airspace users. I mean, all of us, we are sharing the same airspace. There are same constraints. The drones are light. They have limited power supplies, similar to groups represented by Andrea. I mean, there are similarities and common challenges. So what we are trying to do in EASA is to understand those challenges and try to find synergies where the technical enablers will unlock the potential not for a specific group, but for everyone. I've seen the question about would you accept mandating this airspace by eConspicuity for everyone? The same question could be reverted towards the drones. Would you accept, and I can come up with a very stringent requirement for drone industry, but we will not move forward with these kind of questions. We need to start think what's feasible, what we can deliver, and what we can utilize out there for the benefit of safer skies for everyone, not for only specific community. And I can reassure you, knowing the GA environment very well, and the same goes for Sasha and Andrea, people are very conscious about risks. We have seen greater voluntarily equipage by FLARM, even outside competitions, I must admit, in gliding, and also the specific standard for paragliding community, because they have seen the benefit. And the benefits were not use-based at the time. And last word about mobile telephony, and I think I will stop there, is we were selling we were saying that the telecom are selling SIM cards, but I think they are not selling the SIM card. They are selling service. You get the SIM card free. The kit you get free, or you can even get mobile phone, smartphone for free if you subscribe to reasonably priced service. And I think this is what's happening. It will be answering on one of the questions there. What we see, these mobile apps are not thinking of taking money from this basic functionality, this fundamental, the foundation of conspicuity to be seen. they will provide you other benefits like in-flight connectivity or other things there, where they will ask for subscription. So the basic thing will be for free, most likely, and it's already happening today, but the additional services will pay for this. And not everybody needs to go for it, but many people will go. Over to you, Sasha.
I think this is all very encouraging, what we hear. It seems that we have succeeded in taking a moderating role to bring the stakeholder groups together, to get their buy-in, to put their heads together,
Their help as well.
and their assistance and support in moving the things. And I know that we have been wrestling for a long time this the tragic series of, I mean, we have statistics in EASA, the number of mid-air collisions, notably in the lower airspace band amongst GA is tragically and remains to be high. And it took us a long time really to get a grip on this. We have this in our GA safety roadmap for a long time as an action, and there were numerous blocking points. So it seems to me that with this U-Space implementation, interestingly, we have a game changer potentially in moving things such that when we speak about collaborative electronic conspicuity that is affordable, that is so obviously we also have the technology, but the technology was also there before. No, 4G, 5G is nothing new. Yes, thank you very much. We're getting there in a moment. But I just had one question before, and that now goes a bit away from the willingness of the actors to make it happen to the technical feasibility. One of the things is is the technology really ready? Because, for example, one of the things was here, what's the tilting of the antennas, stuff like this. I mean, does it play a role? Is it a factor? And here is where your services come to play. How reliable is connectivity in which altitude, in which given region? Please, who wants to take that?
Happy to start with it. Of course the antenna is important. And of course the antenna on the receiving end is also important. And the question is, so up to what limit? The answer is, it depends. But there are multiple answers to that and multiple solutions. Just think about, so for the lower airspace, we see that most of the airspace is up to 150 meter. There is actually, the signal is not the problem. Many times it is the interference that is the problem, that is actually causing, like if I stand up or hover above you, I see you all. From here, I don't. The same happens to a drone or anything flying on the cellular network. If it's above the cell tower, it gets just so many signal contributions that it's not the signal, it's the interference that kills you. But technology is evolving. What you have these days is you can do dedicated slices in the same physical network, so you can configure virtually today a network up there that behaves very different on the same infrastructure than the network on the ground. It's called slicing. So that technology is existing today and being deployed. That is number one. Number two, there are actually countries today building out high-rise towers of a height of 200 meters with cell radius 90 kilometers to actually serve the lower airspace. For example, just naming two countries where I'm aware of it, Sweden is one of them, where there's a lot of country with not that much population, to serve actually airspaces and services that are there. In the UK is the same thing. There is a network that is built to actually, a cellular network, built to serve up to, I think it's 1,500 meter. Get connectivity in the low airspace. So this is there. And with the called private networks, we see that evolving like big time because the investment is actually, pretty decent. So it's up to, but it depends, is the answer. And this depends, this uncertainty, we remove by providing the information, accessing all the necessary data, processing it, and providing it as a service to everybody who is in need.
Thank you, Thomas. So we are reaching almost the end of our time allotment. I'd like to address a few more questions that I see here. The next one, number 2, no, the first one, which is on the top now, is I think something that is for my colleague Vlado. Where is it now? Now it's number 2, so they compete. So is ADSL an alternative to network remote ID? If not, what is its added value?
I'm not sure I can speak about the kind of mandating ADSL for drones, because maybe Sasha would be better to answer that, and the colleagues in the drone section. But we have designed or specified ADSL also with the drones in mind, especially to be able to bring information about drones into the cockpit of GA aircraft. Because we understand that not everyone is interested in drones to be seen in the cockpit, but particularly paragliders in certain areas may be very much interested in seeing the drones, especially the open category drones, visual line of sight operations, because they are flying in the touristic attractive areas, and there are also people who are making pictures from the drones. So it could be a good a safety barrier to see drones. So that was at the back of our mind, and therefore we have tried to develop a specification that is usable that way as well. What we see now, recent things after we have released the specification, we have been discussing this ADSL topic for a while. We see interest coming from the drone community also to use it for their tracking perspective. And I cannot comment on that, but it could be, I can imagine, a good way of demonstrating the tracking, and with network remote ID over the cellular, it could also unlock the potential of cellular there. So. Okay. And just one important statement here on ADSL. ADSL provide for privacy. So there will be no possibility, if user selects, to track them down like they do it for famous actors and figures through ADSB, which is unfortunately, not having that option there.
Thank you, Vlado. Quickly on the second one. Who will be responsible for the handling of the data transmitted by ADSL? And who will pay for the service? Anything that you might wish to share here?
Responsibility of the data and handling of it. I think there'll be multiple actors, of which we are one from a UTM perspective. And as a technology company, then ultimately the responsibility lies with us at the technical level, and then with our customers and how they have their processes to manage that data as well. So whether that be ANSPs or operators, but those processes will need to be in place. And Thomas, I know from your side of things, one of the things that you bring from Airborne RF is providing that security, that GDPR compliance of the data itself, so that you can't identify individuals from there.
Thank you, Toby. Anything you want to quickly chip in on this, Thomas?
No, it's. I think the technology is there. Yeah. I think it will be a question on who is actually providing the service from an authority perspective. To have it like in a SIS environment, there is no challenge to technically provide that to a central point and update it on a regular basis. The technology for that is available.
Vlado?
I will just conclude on this ADSL for mobile. What we see today, and that's reality, is the app developers are keeping their servers running. And I've mentioned earlier, there is this add-on services. They are paying for this baseline service. So they are paying for the service. So it's the apps who are riding it, and then they open those data through API to use space service providers, and they mutually exchange data.
Thank you, Vlado. Last one for Andrea, a very quick one, please. I know it's a little bit against the. No, hang on a second. I have the next question for you, Andrea, and that is the question from Kevin Wonstrecht to EAS. Are you in favor of an ADSL e-conspicuity mandatory zone across Europe if the costs are in the 0 to 5% cost margin for all the categories? Your quick answer, please.
My quick answer is yes, could be. Could be. We have to discuss with the owners of the.
I think I mentioned Andrea is also a lawyer at the beginning.
Yeah, yeah. But the second point that I want to enlighten is that during the incoming weekend, Easter weekend, 350 paragliders will jump from Monte Grappa, 7,500 feet, very close to the Venetian area in Italy, for a competition valid for the European championship, fully visible with a route of 100 kilometers they have to cross to fly across, fully visible thanks to the existing network of 5G, 4G, 5G provided by the four major mobile phone operators of Italy, without any request to them and without any cost.
So that's a striking example. Thank you very much, Andrea. It brings us to an end of our panel. I would like to let you go with 3 takeaway statements that we had discussed previously and that we would like to offer to you to reflect on, okay, as a result of this topic. Statement number 1. Technology is ready, but aviators want visibility where network coverage is or is not available. Think of that. Statement number 2. ADSL is an enabler for continued affordable access to airspace, also used by unmanned aircraft in the future, and is ready for use by unmanned aircraft already as well. Statement number 3. Use-based development seems to be a catalyst to additional benefits to all low-level airspace participants, such as enhanced situational awareness and data uplink by using mobile telephony technology. With this, I say thank you very much to my panelists. Thank you for spending time with us. And it's precious time. There's a lot going on here. I hope to see some of you back for our subsequent session on an equally interesting topic on the demonstration of eVTOL aircraft across Europe. For now, thank you very much. I hope there was something in it for every one of you.